All right, now let's look at the last tutorial question for the chapter Work and Energy. The 20 kg rod is released from rest when theta equals to 0 degrees. Determine its angular velocity when theta equals to 90 degrees and the spring has an unstretched length of 0.5 meter. Now, let's draw the initial and final position. So when theta equals to 90 degrees, when theta equals to 0 degrees, the rod is here. So this will be the initial position of the rod. Okay. Now, after it has been released, and because of the spring, the rod will travel in this direction, going up into the second position, which is here. Okay, so now this involves the change of height, and therefore we have delta y here, and also this involves spring, so we're going to have two types of work done here. So let's look at the work done by the weight first. UW is equal to minus delta y times the weight, and you see here the total length of the rod is 2 meter, so half of it, delta y is moving here going up, so this must be half of the length of the rod, which is 1 meter. So you have minus 1 here because this is going up, so delta y will be positive 1, and therefore we're going to have negative work done by the weight because the rod is going up. So you have minus 196.2 joule. Now we're going to have to calculate the work done by the spring US. And in order to calculate US, we need to know what is S1 and S2. These two are the elongation of the spring. So if you look at this, we need to find what is this length of the spring first. This is the initial elongation of the spring. So to get this, we can draw a big triangle like this, okay, to use the trigonometry to find the length of that. So we know that up here is 2 because it is given here 2 meter, and because this is 1 meter over here and the length of the rod is 2, so basically we have this part here as 3 meter, okay, like I have written over here, 3 meter. Okay, now I'm gonna erase this first. All right, okay, so we have using the theorem Pythagoras, we know that h here, h is basically the length of the spring initially is equal to 3.6 meter, but this is not S1. This is not S1 because that is not the elongation of the spring. This is not S1. Okay, please be careful. Many students make mistake about this. And you notice in the question that it says unstretched length is 0.5. So what is basically S1? S1 is the length of the spring you have to minus with the unstretched length. So basically unstretched length is the original length of the spring. So basically S1 is the total length of the spring initially 3.6 minus the unstretched length. So you have S1 equals to 3.106 meter. What about S2? S2 is at position number 2, you see that this is the length of the spring, 1 meter. But is that S2? No. S2 is 1 meter, you have to minus the unstretched length. So basically at both position, at position 1 and at position 2, the spring is not at its original length, because its original length is 0.5, and both initial and final position, the length of the spring is longer than the original length, so it is stretched at both position. Okay, please be careful with this, because you don't take 1 here as S2 for position number 2. This is not S2 also. S2 is basically this length minus the unstretched length. Okay, so then we have all the values we can key in the equation to get US is equal to 469.86. Okay, so you see here from stretch, a lot of stretch, it goes into little stretch of the spring, so the work done by the spring becomes positive. Okay, now again it says release from rest, so you know that initial KE equals to 0 because starts from rest, and this is point A, the center of rotation. T2 can be calculated using 1 over 2 IA omega 2 square, because this is a pure rotation. So to get IA, you have to know IG and use parallel axis theorem. Okay, IG is 1 over 12 ml square. This is a rod. Refer to the table. So you have 6.67 kg meter square, and use parallel axis theorem. Okay, this is the parallel axis theorem. 6.67 plus m is 20. D is the distance from center of gravity. This is G to the center of rotation A. So this is D, which is half of the length, so it's equal to 1. So you have the IA is 26.67 kg meter square, and therefore T2, you will then replace or substitute this value in, so you have 13.3 omega 2 square. Now we apply the principle of work and energy. Okay, work and energy, it says that initial kinetic energy T1 plus total work done equals to T2, the final kinetic energy. T1 equals to 0. Total work done is the UW plus US, so equals to this, and equivalent to T2, 13.3 omega 2 square, and finally you will get omega 2 is 4.531 rad per second.